Hello students, welcome to Breedmark Academy. Myself LS Nanda. As I promised you people that I will be presenting before you 3 videos that will be based on my book Golden Problems in Mathematics. So here is the third video which I am going to share with you people. I hope you must have watched 2 videos that I posted earlier. If you haven't gone through them, then I will suggest you people to please watch those videos as well. Now in this particular video again I am going to discuss detailed solutions of 10 questions randomly picked from my book. Now here is the first question. You can see it's a question based on the concept of indefinite integration. Now it's a special problem because it involves all the trigonometric functions. Now to solve this question, what I'm going to do, I will be using trigonometric formulae like sine square theta plus cos square theta, which I can write as 1. Then tan square theta, cot square theta, secant square theta, cosecant square theta. By trigonometry we know that they can be written in terms of sine theta and cos theta. Like tan square theta can be written as sine square theta upon cos square theta. Fine. Similarly, cot square theta can be written as cos square theta upon sine square theta. And then secant square is 1 upon cos square and cosecant square is 1 upon sine square. Now let's do the calculations. First of all, take the LCM. Now this is 1 plus, for these two terms the LCM is going to be sine square theta cos square theta. Fine. And here I will be writing sine theta power 4 plus cos theta power 4. And for these two terms again the LCM is sine square theta cos square theta. And in the numerator I will be getting sine square theta plus cos square theta, which can again be written as 1. Fine. Now to solve this expression further, what I am doing, this sine theta power 4 plus cos theta power 4 part can be written as what? It can be written as sine square theta square plus cos square theta square. Now we know that a square plus b square can easily be written as a plus b whole square minus 2ab. So by that identity, this expression can be written as sine square theta plus cos square theta whole square minus 2 sine square theta cos square theta. Fine. Now sine square theta plus cos square theta is nothing but 1. So that means this second middle term we can write as 1 minus 2 sine square theta cos square theta whole divided upon sine square theta cos square theta. Fine. And the third term is just 1 upon sine square theta cos square theta. Now we move further. Now this expression can be written further as d theta upon 1 plus, when we separate the terms of the middle term, we get here 1 upon sine square theta cos square theta minus 2. Fine. And then we had the last term as 1 upon sine square theta cos square theta. Let us collect these terms now. We'll be getting d theta upon 2 upon sine square theta cos square theta minus 1. Fine. Now take the LCM again. You will be getting sine square theta cos square theta in the numerator into d theta divided upon 2 minus sine square theta cos square theta. Now students, we know that sine theta into cos theta into 2 can be written as sine 2 theta. So that means this expression can further be written as 1 upon 4 into sine square 2 theta d theta divided upon 2 minus sine square theta cos square theta. Now what do? We take this 4 and multiply it with the terms of the denominator. So now we get sine square 2 theta d theta divided upon 8 minus 4 sine square theta cos square theta, right? Now this can further be written as sine square 2 theta d theta divided upon 8 minus sine square 2 theta. Why? Because sine 2 theta is equal to 2 sine theta into cos theta. Now we move further. Now we had the expression as sine square 2 theta d theta divided upon 8 minus sine square 2 theta. Fine. To solve it, what we can do, we can take minus out like this, and here we have minus sine square 2 theta, add 8 and subtract 8. Why? Because I want to divide it by the denominator. Now this can be written as minus integral 1 minus 8 upon 8 minus sine square 2 theta d theta. Fine. So this can clearly be written as minus theta plus 8 into integral d theta upon 8 minus sine square 2 theta. Right? Now further we can simplify this as, now this is sine square 2 theta. First of all, we can do the substitution that 2 theta is equal to t. So that means 2 d theta will become dt. Fine. So this d theta part can be written as half dt. So it becomes 4 into dt upon 8 minus sine square t. Fine. Now we move further. Now we had the term as minus theta plus 4 times dt upon 8 minus sine square t. Right? Now students, what we can do here, this is minus theta plus up and down in this integral, we can divide by cos square t. So here we'll be getting secant square t dt, and this is going to be 8 upon cos square t, which will become 8 secant square t minus sine square t upon cos square t, it becomes tan square t. Fine. Let's solve it further. This is minus theta plus 4 times secant square t dt. Now this secant square t can be written as 1 plus tan square t. So it comes out to be 8 plus 8 tan square t. So this is nothing but 8 plus 7 tan square t. Fine. Now it's obvious that we have to put tan t as z, because secant square t dt will become dz. Fine. So it becomes minus theta plus 4 times secant square t dt becomes dz. In the denominator we have 8 plus 7z square. Now it's very much simple. Just take 7 out. So it becomes 4 upon 7 dz, and this is going to be 8 by 7. So we can rewrite this as under root of 8 by 7 whole square plus z square. Now students, this integral can be easily solved by the formula dx upon x square plus a square. And we know that dx upon x square plus a square is just 1 upon a tan inverse x by a. So that means this can be written as minus theta plus 4 by 7. 1 upon a means root 7 upon root 8 into tan inverse z upon root 8 by root 7. Fine. So it becomes root 7 into z upon root 8 plus c. Fine. Now we move further. Now students, this expression can be simplified as minus theta plus under root of 2 by 7 into tan inverse of root 7 z upon 2 root 2 plus c. Fine. Which can be further written as minus theta plus under root of 2 by 7 into tan inverse. What was z? It was tan t, and t was 2 theta. So it can be written as tan 2 theta whole divided upon 2 into root 2 by root 7, or under root of 2 by 7 plus c. Fine. Now, as per the question, if we take the value of k as under root of 2 by 7, or we just make the comparison with the value which is given in the question, then k is just under root of 2 by 7. So now this can be written as minus theta plus k into tan inverse of tan 2 theta divided upon 2k plus c. Fine. So the answer is the value of k is equal to under root of 2 by 7. Now students, this is the second problem. The question says if x comma y are real numbers such that they satisfy the given equation, then we have to find the range of the expression x square plus y square minus 8x minus 4y plus 25. Now if you have gone through the concepts of coordinate geometry, then you must be knowing that equation of the form under root of x minus x1 square plus y minus y1 square plus under root of x minus x2 square plus y minus y2 square, where x1, y1, x2, y2 are real numbers equal to 2a, or we can say k, then this sort of equation will represent ellipse if the distance between the points x1, y1 and x2, y2, let's say these 2 points are a and b, if this distance AB is less than 2a, right? Now, if you calculate the distance in the above equation between the points 1, 2 and minus 1, 2, then clearly it is going to be 2 units, right? In our question, AB is equal to 2 units. And the value of the constant on the right hand side, that is 2a, is equal to 4. So we can clearly say 2 is less than 4. So that means this equation certainly represents the equation of the ellipse with the foci as 1, 2 and minus 1, 2, right? And the value of 2a in this ellipse is going to be equal to 4. Fine. Now we move further. Now let me draw the rough sketch of this ellipse. We have obtained the foci as minus 1, 2 and 1, 2. So suppose this is minus 1, 2 and this is 1, 2. If we draw the sketch of this ellipse, obviously if you calculate the value of b, you'll come to know that it is not going to touch the x-axis. Fine. The center will be the midpoint of these two foci. So hence we can say the center is going to lie at 0, 2. Fine. Let me draw the major axis of this ellipse. Obviously this is going to be a horizontal ellipse. Now students, we have to calculate the range of the expression x square plus y square minus 8x minus 4y plus 25. Fine. Let us see what is represented by this expression. You can rewrite this expression as x minus 4 whole square plus y minus 2 whole square. Now when you expand this expression, you will be getting x square plus y square minus 8x minus 4y plus 20. So that means I can just add 5 to it so as to make it equal to the above expression, that is x square plus y square minus 8x minus 4y plus 25. Fine. Now x comma y is the general point of this ellipse. Now to calculate the interval or the range for this particular expression, what we need to do, we have to basically find the minimum and the maximum distance of the point 4, 2 from any point lying on this ellipse. Are you getting what I am trying to say? That means we have to calculate the minimum and the maximum distance of this ellipse from this given point 4, 2. Because if I calculate that thing, that will help me to find the maximum and minimum values of x minus 4 whole square plus y minus 2 whole square, and after that we will just add 5 to it to get the range of the given expression. Now students, if you are well aware about the law of coordinate geometry, then you must be knowing whenever we have to calculate the minimum and the maximum distance of the point from any curve like ellipse or hyperbola, we have to basically draw a normal from that point to that given curve, because all sort of distances, whether maximum or minimum, will always lie along that normal. Now normal means in this particular case we have to just extend the major axis such that this point 4, 2 will lie on it. Why I'm saying it is going to lie on it? Because the equation of the major axis in this case is just y is equal to 2. So 4, 2 will definitely lie on it. Now, if suppose this is the point P, let's say this is C, this is D, then the minimum distance of the ellipse from the point 4, 2 is going to be PD. And PD is how much? Because we have already calculated the value of 2a as 4, and you must be knowing that 2a is the length of the major axis. Now this was 0, 2 as the center. So this particular distance must be equal to how much? It should be equal to 2, because a is coming out to be 2. So that means this particular point can be written as 2, 2. The coordinates of the point D will be 2, 2. And similarly, the coordinates for the point C will be minus 2, 2. Fine. So that means easily I can find the distance of PD as just 2 units. Fine. Similarly, the maximum distance is going to be PC, and that is going to be 4 plus 2, that is 6. Fine. So now I know that the expression under root of x minus 4 whole square plus y minus 2 whole square will lie between 2 to 6. Why? Because we have found the maximum and the minimum distances of the point 4, 2 from the ellipse, and they are coming to be 2 and 6. Now let us square this quantity. If we square this quantity, we will be getting x minus 4 whole square plus y minus 2 whole square lying between 4 to 36. Fine. And if we add 5 to this given inequality, then what do we get? We get the range for the given expression, and that comes out to be between 9 to 41. Right students? So closed interval 9 to 41 is our required answer, or the B option is the correct one. Now it was a fantastic question based on the concept of minimum and maximum distances. Such kind of questions are generally asked in competitive exams. Now we move to our next problem. Now students, this third problem is based on the concept of functions. The question says if the function f colon close 3 to 5 going to close minus 58 to 110 given by fx equal to x to the power 4 plus kx cube plus lx square minus 24x plus 5 is 1 1 on 2, then we have to find the value of 3k plus 2l where both k and l are integers. Now as we notice in this question, fx is a polynomial function, and we know that polynomial functions are always continuous, right? Now additionally, in this particular question it has been given that this function is 1 1 on 2 as well. What does it mean? It means either this function fx will be throughout increasing in closed 3 to 5, or fx will be throughout decreasing in this particular interval. Right? That means the function is not going to have dual behavior. Either it will be consistently increasing or it will be consistently decreasing. Now let's consider the first case. If the function is increasing, then f of 3 will be equal to minus 58 and f of 5 will be equal to 110. And in the second case, f of 3 will be equal to 110 and f of 5 will be equal to minus 58. Right? Now we move further. Now students, let us solve the first case. Since f of 3 is minus 58 and f of 5 is equal to 110. So now I can write the value of f of 3 by putting x equal to 3 in the given function, and that will come as 3 to the power 4, that is 81, plus 27k plus 9l minus 72 plus 5 equal to minus 58. Now let us solve this equation. We'll be getting 27k plus 9l equal to minus 72. Right? This is going to be the first equation. Now we find the value of f of 5 by putting x equal to 5 in the expression of fx. We'll be getting 625 plus 125k plus 25l minus 115 equal to 110. Now if we simplify this expression, we'll be getting 125k plus 25l is equal to minus 400. Or if we divide by 25 throughout, we'll be getting 5k plus l equal to minus 60. Right? Let's consider this as the second equation. Now we'll be solving these two equations 1 and 2 mutually. If we multiply the second equation by 9, we'll be getting 45k plus 9l equal to minus 144. Let's call it the equation 3. And if we subtract equation third from equation first, what do we get? We'll be getting 27k minus 45k, that is minus 18k equal to 72. Or in other words, k will be equal to minus 4. Right? And if we substitute the value of k equal to minus 4 in the equation number 2, we'll be getting minus 20 plus l equal to minus 16, or l equal to just 4. So that means now I can find the value of 3k plus 2l as 3 into minus 4, that is minus 12, plus 2l is 8. So final answer is minus 4. Fine. And this particular set of values of k and l are also integers. So that means according to the question, this must be our final answer. But we have just considered the first case. Now we have to check it whether by putting these values we get the function as increasing or not. And secondly, we also need to find the set of values of k and l for the second case. Now students, fx was given to us as x to the power 4 plus kx cube plus lx square minus 24x plus 5. Fine. Now if I put the values of k and l which we have obtained in this function, the function becomes x to the power 4 minus 4x cube plus 4x square minus 24x plus 5. Fine. Now let's differentiate this. Then the value of f dash x is going to be 4x cube minus 12x square plus 8x minus 24. Now if you just factorize this expression by using grouping technique, it becomes 4x square, and inside the bracket it becomes x minus 3, and here take 8 common, it becomes x minus 3, and finally we can write this as x minus 3 into 4x square plus 8. Now why I'm doing this? I just want to ensure that for the closed interval 3 to 5, this function will be increasing. And you can clearly see, since for closed 3 to 5, x minus 3 will be positive, and 4x square plus 8, since it's a quantity comprising of positive number plus a perfect square, so it will always be positive. So that means I finally conclude that f dash x is greater than 0 in closed 3 to 5. In fact, at x equal to 3, it will become 0. So we can also put f dash x greater than or equal to 0. So we finally say that fx is an increasing function, right, in closed interval 3 to 5. So that means this particular set of values k and l satisfy the requirements of the question, and hence they are one part of the answer. Now why I'm saying one part of the answer? Because I have not checked the second case. Now let me move to the second case to find whether while solving that particular case I will be getting the values of k and l as integers again or not. If we get the values of k and l again as integers, then they will also form the second part of the answer. And if we do not get them as integers, then only this will be your answer. Fine. Now students, in the second case, if we try to solve for the second case, then f of 3 is 110 and f of 5 is equal to minus 58. If we equate the value of f of 3 equal to 110, we'll be finally getting 27k plus 9l equal to 96. And if we put the value of f of 5 equal to minus 58, we'll be getting 125k plus 25l equal to minus 568. Fine. And if you try to solve this set of equations, clearly you can see the answer for k will be going into in the fractions. It is not going to be an integer. Now let me show you. If we divide the second equation by 25, we'll be getting 5k plus l equal to minus 568 divided by 25, right? Now this is our second equation. This is the first one. To solve first and second equation mutually, let me multiply the second equation by 9. I'm using coefficient elimination technique, so it becomes so much. I am not interested to find this complicated value. I am just trying to show that when you subtract now, you'll be getting minus 18k equal to 96 plus 9 into 568 divided by 25. And when we divide by minus 18, it's very much clear that k will be in fractions, or it is not going to be an integer, right? And clearly this particular option or this particular case is ruled out as per the requirements of the question, because it was given that we have to find the values of k and l as integers. So that means we will remove this case. So hence our answer will come from the first case only, and that is 3k plus 2l will be equal to minus 4. So finally 3k plus 2l is equal to minus 4 is our final answer, right? So hence A option is the correct one. Now students, this was a nice question involving the concept of functions. Now we move to our next problem. Now students, this is our next problem. It's a simple question but involves a very important concept. The question says if A is the set of first 10 natural numbers, that is A is the set comprising of numbers like 1, 2, 3 and so on till 10. Then the number of non-empty subsets S of A such that 3, 5 and 7 do not simultaneously belong to S. That means we have to find the total number of non-empty subsets S of A such that 3, 5 and 7 must not occur simultaneously in them. S may be of the form like 3, 5 or 1. Fine. It may be of the form like 1, 5, 7 and so on. I hope you must have got the meaning of the question. Now, to solve this problem, first of all, let us find the total number of non-empty subsets of the given set A. Now, since A is having 10 elements, so by the formula, if a set has n elements, then the total number of its subsets is 2 to the power n. And since every set contains empty set as its subset, therefore, we will be subtracting 1 from 2 to the power 10. Right? Why I'm writing 10 over here? Because A has 10 elements. So this value comes out to be 1023. So that means 1023 is the total number of non-empty subsets of this set A. Now, what should be the approach of the solution? Now I will be finding the total number of subsets of A such that they will always have 3, 5 and 7 as its member, like 3, 5, 7 only, or 3, 5, 7 and 4, or 3, 5, 7 and 1, right? The number of elements in this subset may be 3, maybe 4, maybe 5. Obviously, it should be at least 3, but it can go till 10 elements, right? And what should be the common point in all these subsets? 3, 5 and 7 will always occur in them. Are you getting my point? Now let's move further. Now students, to find the total number of such subsets, what we'll be doing? We will be using the concept of combinations. Now suppose for the set 3, 5 and 7, only having 3 elements 3, 5 and 7, I will be writing 7C0. Then I will be counting those subsets which will have 4 elements. So 3, 5 and 7 will be the 3 elements, and the remaining 1 element I will be selecting from the other 7 elements. So that means it will be 7C1. Similarly, for those subsets which will be having 5 elements, 3 will be 3, 5 and 7, and remaining 2 I will be selecting from the other 7 elements. Are you getting my point? So this process I have to continue till 7C7. And you must be aware of the formula NC0 plus NC1 plus NC2 and so on up to NCn is equal to 2 to the power n. So by this formula, the value comes out to be 2 to the power 7 or just 128. Fine. Now these subsets I do not want. That means they are unwanted subsets. So now students, this is a wonderful problem based on the concept of geometry of complex numbers. The question says if Z is a complex number satisfying these two given equations simultaneously, then we are supposed to find the value of square of mod of Z minus 3 minus 4 iota plus square of mod of Z plus 4 plus 3 iota. Now, such kind of questions are very much suitable for exams like JEE Advanced, because this particular problem involves in-depth knowledge of concepts. Only those students who have done a lot of practice on the geometry of complex numbers will be able to solve such kind of problems. Now, in this question, as I said, if you are well aware about the concepts of geometry of complex numbers, then you must be knowing that any equation of the form square of mod of Z minus Z1 plus square of mod of z minus z2 equal to square of mod of z1 minus z2 will always represent the equation of a circle in the Argand plane, where z1 plus z2 by 2 will represent the center of this circle, right? And the radius will be given by mod of z1 minus z2 divided by 2. Now, if we make the comparison between this equation and the given equations, and let us consider the first equation now, mod of z minus 5 minus 7 iota square plus mod of z minus 1 minus iota square equal to 52. Then you can clearly see, if we make the comparison and I take z1 as 5 plus 7 iota and z2 I'm taking as 1 plus iota, that means this point will be 5 comma 7 and this point in the Argand plane will be 1 comma 1. Then clearly mod of z1 minus z2 is going to come as under root of 4 square, this is 16, plus under root plus square of 7 minus 1, that is 36. So this value comes out to be under root of 52, right? And obviously if I make the comparison, then the square of mod of z1 minus z2 will be how much? It will be just 52. So that means this equation verifies that the given equation represents a circle whose center will be the midpoint of z1 and z2. That means z1 and z2 are going to be at the ends or the endpoints of a diameter, right? And the radius is going to be mod of z1 minus z2 divided by 2. Fine. Now we move further. Now students, if you just write the equation of this circle in the terms of coordinate geometry, that is in terms of 2D plane, then you can rewrite the equation of the circle as x minus x1 square plus y minus y1 square equal to r square. This is the standard form of the circle where x1 y1 is going to be the center. Now let us find the coordinates for the center now. Since it is z1 plus z2 divided by 2, so it is going to be 5 plus 7 iota plus 1 plus iota divided by 2, or it is going to be 3 plus 4 iota. Fine. So that means the coordinates of the center for this circle will be 3 comma 4. Now similarly the radius is going to be mod of z1 minus z2 divided by 2. Now since mod of z1 minus z2 was under root of 52, so it is going to be under root of 52 divided by 2. Or if we simplify this, we get 2 root 13 divided by 2, or just root 13. So that means the equation in terms of coordinate geometry, it is going to be x minus 3 square plus y minus 4 square equal to 13. Or if I just simplify it, it is going to be x square plus y square minus 6x minus 8y plus 12 is equal to 0. Fine. Why I am converting this in terms of coordinate geometry, you will come to know just now. Now what you have to do, you have to do the same process for the second given equation. Now if we consider the second equation, the equation is given to us as mod of z minus 5 plus iota square plus mod of z plus 13 plus 5 iota square mod of z plus 13 plus 5 iota whole square equal to 340, right? Now here if we make the comparison with the standard equation that I wrote when I started the question, z1 will be 5 minus iota and z2 will be minus 13 minus 5 iota. And if we find the value of mod of z1 minus z2, clearly it is going to be under root of 5 plus 13 whole square, that is 324, plus minus 1 plus 5 whole square, that is 4 square, so it is 16, or this is just under root of 340. So it confirms that this equation also represents a circle whose center will be located at the midpoint of z1 and z2, that is the midpoint of the points 5 comma minus 1 and minus 13 comma minus 5, and the radius of this circle is going to be under root of 340 divided by 2. Fine. Now we move further. Now if we transform this equation in terms of coordinate geometry, then you can clearly see the coordinates of the center for this second circle will now be 5 minus iota minus 13 minus 5 iota divided by 2, or the fx of this center comes out to be minus 8 minus 6 iota divided by 2, or minus 4 minus 3 iota. So that means the coordinates will be minus 4 comma minus 3. And similarly, if we find the radius for this circle, then it is going to be under root of 340, as I told you earlier, divided by 2. Let us just simplify this value. So it is under root of 17 into 2 into 2 into 5, or this value comes out to be 2 under root 85 divided by 2. So it is just under root of 85. So that means in terms of coordinate geometry, the equation turns out to be x plus 4 whole square plus y plus 3 whole square equal to 85. Fine. So that means the equation becomes x square plus y square plus 8x plus 6y plus 16 plus 9, that is 25 minus 85. So it is minus 60 is equal to 0. Now students, if you calculate the distance between the centers of these two circles, the distance comes out to be under root of 3 plus 4 whole square, that is 49, plus 4 plus 3 whole square, again it is 49. So that means it is 7 root 2. And you already know the values of R1, that is the radius of the first circle, that was under root of 13, and R2, that is under root of 85. Fine. Under root 13 is approximately 3 point something, and under root 85 is something 9 point something. Now roughly I can say D lies between, because this D is 7 root 2, so again it is 9 point something. It will lie between mod of R1 minus R2 and R1 plus R2. So that means we can clearly say that these two circles will intersect each other in two distinct points. Now this information is really going to help us. Now students, we have obtained the equation of the two circles as x square plus y square minus 6x minus 8y plus 12 is equal to 0. This is the equation of the first circle. And the second we have obtained as x square plus y square plus 8x plus 6y minus 60 is equal to 0. As I have already told you, these two circles are going to intersect each other in two distinct points. Now, what is another thing that is going to be special about them? They are not only going to intersect each other, in fact, they are going to intersect each other orthogonally. Now, why I'm saying this thing? If you are well aware about the concept of orthogonality, then you must be knowing if any two circles satisfy this particular condition, then those two circles always intersect each other orthogonally. That means the radius of one circle will act as a tangent to the another one, right? Now, let us put in the values and check it whether it happens for these two circles or not. Now, this is going to be 2 into minus 3 into 4 plus 2 into minus 4 into 3 equal to 12 minus 60, right? On the right hand side we get minus 48, and here if we do the calculations it becomes minus 24, again minus 24. So clearly minus 48 is equal to minus 48. So that means equation 1 and equation 2, both of these circles are going to intersect each other orthogonally. And since these two circles are going to intersect each other orthogonally, then now what I can say, let's make the rough diagram. Suppose this is the point Z, because it was initially given to us Z is a complex number satisfying both the circles, that is it is lying on both the circles. So obviously it is going to be the point of intersection. Now whenever two circles intersect each other, then you can clearly see from here this diagram that if I just join the centers of these two circles, let's say the distance between their center C1 and C2 is D and their radius are R1 and R2, then clearly this angle is 90. So by Pythagoras theorem, D square is equal to R1 square plus R2 square. Fine. And if you have understood this thing, then now the answer is almost obvious. And now let us move towards the answer. Now let us assume that these two circles are intersecting at the point P, whose fx is the common point of intersection, that is Z. That means the Z is the complex number which was lying on both the circles. And let us say the center of the first circle is C1 and the center of the second circle is C2. Then now I can write PC1 square plus PC2 square is equal to C1 C2 square. And C1 C2 square means D square, which is 98 in this case. Now what should be PC1 square? It's simply square of mod of Z minus the fx of the center of first circle, that is 3 plus 4 iota. Fine. Plus square of mod of Z minus the fx of the center of the second circle, this is minus 4 minus 3 iota, equal to 98. So finally we can write square of mod of Z minus 3 minus 4 iota plus square of mod of Z plus 4 plus 3 iota is equal to 98. So obviously C is the right answer. Now students, this was a nice problem based on the concept of geometry of complex numbers. In order to solve such kind of problems, you must have a strong hold over both the topics, coordinate geometry as well as complex numbers. Now we move to our next problem. Now students, this is our next problem. As you can see, this is the question based on the concept of definite integrals. We have to evaluate the integral 0 to pi by 4 1 minus sine square theta upon 1 plus sine square theta plus 1 minus cos square theta upon 1 plus cos square theta d theta. Now you must be familiar with the identity sine square theta plus cos square theta equal to 1. So by using it, we can rewrite the given integral as 0 to pi by 4 cos square theta upon 1 plus sine square theta plus sine square theta upon 1 plus cos square theta d theta. Right. Now students, we'll have to first of all simplify the integrand, and that we can do by using trigonometric identities and little bit of algebra. First of all, we'll be taking the LCM of the denominators. We'll be getting 1 plus sine square theta into 1 plus cos square theta in the denominator, and in the numerator we'll be getting cos theta power 4 plus cos square theta plus sin theta power 4 plus sin square theta, right? Now students, cos square theta plus sin square theta is equal to 1 straight away, and for the terms cos theta power 4 plus sin theta power 4, we can write it as like cos theta power 4 plus sin theta power 4, we can break as cos square square plus sin square square. That means it can be written as cos square theta square plus sin square theta square, which can further be written as cos square theta plus sin square theta whole square minus 2 cos square theta sin square theta. So that means it is finally 1 minus 2 sin square theta cos square theta. Fine. Now I will be using this expression in this simplification. Now our given expression will become 1 minus 2 sin square theta cos square theta in the numerator plus 1. Why 1? Because cos square theta plus sin square theta was equal to 1. And in the denominator, if we open up the brackets, we'll be getting 1 plus cos square theta plus sin square theta plus sin square theta cos square theta. Fine. Now students, finally this expression will become 2 minus 2 sin square theta cos square theta in the numerator, and in the denominator we'll be having 2 plus sin square theta cos square theta. Now we move further. Now students, we were having the expression 2 minus 2 sin square theta cos square theta in the numerator, and in the denominator we had 2 plus sin square theta cos square theta. Fine. Now we know the formula sin 2 theta equal to 2 sin theta cos theta. So I'll be using this formula here to make this expression look simpler. So to create sin 2 theta, I will be multiplying numerator and denominator by 2. I will be having 4 minus 4 sin square theta cos square theta in the numerator, and in the denominator I will be getting 4 plus 2 sin square theta cos square theta. Now students, numerator can easily be written as 4 minus sin square 2 theta. But in the denominator, we need to multiply again by 2. So that means we'll be multiplying numerator and denominator again by 2. So in the denominator, now we'll be having 8 plus 4 sin square theta cos square theta, which can be written as 8 plus sin square 2 theta. Fine. So our expression finally becomes 8 minus 2 sin square 2 theta divided upon 8 plus sin square 2 theta. Now students, our integral finally becomes 0 to pi by 4, 8 minus 2 sin square 2 theta divided upon 8 plus sin square 2 theta. Now to solve this integral, what I am going to do here is I will be creating the term in the denominator again in the numerator. That means I will be adding sin square 2 theta and subtracting sin square 2 theta in the numerator. So it becomes 0 to pi by 4, 8 plus sin square 2 theta minus 3 sin square 2 theta divided upon 8 plus sin square 2 theta d theta. Now students, this expression can further be written as, now this integral becomes 0 to pi by 4, 1 minus 3 sin square 2 theta divided upon 8 plus sin square 2 theta d theta. What I have done, I have separated the terms in the numerator and then divided by the denominator. Now it becomes pi by 4 because the integral of 1 d theta will be just theta and the limits are 0 to pi by 4. So it becomes pi by 4 minus integral 0 to pi by 4 Take out 3 common. Now students, we are just left with sine square 2 theta in the numerator. So again add 8 and subtract 8 in the numerator. I am repeating the same process again. Now I will be dividing by the denominator. So now it becomes minus 3 times integral 0 to pi by 4 1 minus 8 upon 8 plus sine square 2 theta d theta. Fine. So finally this expression can be written as pi by 4 minus 3 pi by 4 plus 24 into 0 to pi by 4 d theta upon 8 plus sine square 2 theta. Now students, we can easily integrate this expression. Now I'm doing a little bit of calculations. Pi by 4 minus 3 pi by 4 will become minus 2 pi by 4, which is minus pi by 2, plus 24 into integral 0 to pi by 4. To integrate this expression, I'm using the formula sine 2 theta equal to 2 tan theta upon 1 plus tan square theta. Fine. So when we replace sine 2 theta by 2 tan theta upon 1 plus tan square theta, we'll be getting in the numerator 1 plus tan square theta whole square in the numerator d theta, and in the denominator we'll be having 8 into 1 plus tan square theta whole square plus 4 tan square theta. Fine. So now this expression can be written as minus pi by 2 plus 24. Now students, what I'm doing, I'm putting tan theta equal to t in this integral. So that means secant square theta d theta will become dt. Fine. So our integral now becomes 0 to 1. 1 plus tan square theta is nothing but secant square theta. So secant square theta d theta will become dt. And in the numerator we'll be having 1 plus t square dt. Fine. And what about our denominator? It will become 8 times 1 plus t square whole square plus 4t square. Fine. Because in the entire expression we have replaced tan theta by t. Now students, we move further and solve this integral. Now students, this finally becomes minus pi by 2 plus 24 into integral 0 to 1 plus t square dt. Now the expression in the denominator was 8 into 1 plus t square whole square. So let me simplify this as t to the power 4 plus 2t square plus 1. And then outside the bracket we had 4t square. Fine. So now just take out 4 common from the denominator. And this 4 will cancel 24 by 6. That means it is going to be minus pi by 2 plus 6 times 0 to 1. 1 plus t square dt divided upon 2 into t to the power 4 plus 5t square plus 2. Fine. Now students, this is a particular type of integral. If you have done thorough studies on definite integral, then you must be able to recognize this particular type. To solve this type of integral, what we need to do, we have to divide up and down by t square. That means this is minus pi by 2 plus 6 times integral 0 to 1. It will become 1 plus 1 by t square dt divided upon 2t square plus 2 upon t square plus 5. Now what we need to do is we have to put t minus 1 by t as z. That means 1 plus 1 upon t square dt will become dz. Fine. So our integral becomes minus pi by 2 plus 6 times. Now automatically limits will also change. So when t was 0, the value of z will become 0 minus 1 upon 0, which is minus infinity. And when t is 1, it will become 0. Fine. And in the numerator we'll be having dz. In the denominator we'll be having, it is 2 times t square plus 1 upon t square. Now students, if we square this expression, we'll be getting t square plus 1 upon t square minus 2 as z square. So that means t square plus 1 upon t square is nothing but z square plus 2. So that means in the denominator I will be having 2 times z square plus 2 plus 5. Fine. Now we are just close to the answer. It is minus pi by 2 plus 6 times integral minus infinity to 0 dz upon 2z square plus 9. Fine. So just take out 2 common and then use the formula straight away. Now students, we were having minus pi by 2 plus 6 times integral minus infinity to 0 dz upon 2z square plus 9. Fine. So if I take out 2 common from the denominator, I will be having minus pi by 2 plus 3 times integral minus infinity to 0 dz divided upon z square plus 9 by 2. So 9 by 2 can be written as 3 upon root 2 whole square. Fine. Now students, we have to just use the formula dx upon x square plus a square. And what is that? It is 1 upon a tan inverse x by a. So that means this expression now becomes minus pi by 2 plus 3 times 1 upon a means root 2 by 3 tan inverse z upon 3 upon root 2. So that means it is root 2z upon 3. And the limits are minus infinity to 0. So now just put the limits and get the final answer. 3 will cancel out. It will become root 2 outside. And when we put the limits, that is, first of all, we'll be putting 0. So it will be tan inverse 0, which is nothing but 0. Minus tan inverse minus infinity. Now tan inverse minus infinity is what? It is minus pi by 2. Fine. So we'll be having minus pi by 2 plus pi upon root 2. Fine students. So if I take pi common, I'll be getting 1 upon root 2 minus 1 upon 2. Or if I take the LCM, I'll be getting pi by 2 into root 2 minus 1. So students, this is the right option. It is the option number C. So it was a nice problem, a quite different problem, and such kind of questions can be asked in exams like JEE Advanced. Now students, we move towards the next problem. Now students, this is a wonderful problem on the topic of probability. The question says there are 10 girls G1, G2, G3 and so on up to G10. They are boarding a metro train at station A that will halt at 10 more stations, namely A1, A2, A3 and so on up to A10 after the station A. Now the probability of girl GI alighting the train at station AK is given to be I plus K minus 1 whole divided upon 45 plus 10I. Then we are required to find the probability that both the girls G2 and G3 will alight the train at same station. Now students, it's very much clear that if girl G2 alights at a particular station, then it's not necessary that girl G3 will also alight at the same station. So that means we can consider both of these events to be independent. Now let us first assume that girl G2 alights at a station AK. Let's consider this event as EK. Fine. And let's consider if girl G3 alights at a particular station AK, then this event is FK. Now here it's very much obvious that the values of K will vary from 1 to 10 because there are total 10 stations where any person can alight after the station A, because all of them are boarding the train at station A. So they will be alighting the train at any one of the stations from A1 to A10. Now students, according to the language of the question, now we have to find the probability of E1 intersection F1 plus probability of E2 intersection F2 plus probability of E3 intersection F3, and so on till we have to add till probability of E10 intersection F10. Why I'm adding all of these 10 probabilities? Because we have to consider all the possible cases, because both girls may alight at station 1, they may alight at station number 2, or they may alight at station number 3, and so on till station number 10. Clear? Now we have to use the theorem of independent events, that is the multiplication theorem of independent events, and solve this problem further. Now this expression can further be written as Pe1 into Pf1 plus Pe2 into Pf2 plus Pe3 into Pf3. I am just using the multiplication theorem of independent events, and we have to go till Pe10 into Pf10. Fine. Now let us use that formula which is given to us in the question itself, the formula to find the respective probabilities, and we'll be just putting in the values. Now Pe1 will become 2 upon 65. Students, you have to just place the value of k as 1 and the value of I as 2, because this is the probability for the girl number 2. And for girl number 3, you have to place the value of I as 3 and k as 1. Why I'm putting k as 1? Because it's station number 1. So this is 3 upon 75, right? So similarly, keep on putting all these values. You will be getting this particular series. And so on till 11 upon 65 into 12 upon 75. Fine. Now what do? We take out this 1 upon 65 into 75 common, and inside the bracket we get 2 into 3 plus 3 into 4 plus 4 into 5 plus 5 into 6, and so on till 11 into 12. Fine. Now students, if you have proper knowledge of sequences and series, you can easily understand this can be written as now summation of I into I plus 1, where I varies from 2 to 11. Fine. This can further be written as 1 upon 65 into 75. Now to give it a proper shape, what I am doing, I am writing it summation I into I plus 1, where I varies from 1 till 11, and subtracting the value of this expression if the value of I is 1. That means the value of this expression I into I plus 1 will be 2 if I put I as 1. So I'm just subtracting it because it was not present in the expression. Now this can further be written as 1 upon 65 into 75 into, let's break it, it becomes summation of I square, that is the sum of first 11 natural numbers, the sum of the squares of first 11 natural numbers. Then we have the sum of first 11 natural numbers and minus 2. What I have done, I have just broken down this series. Fine. Now we'll be just putting those formulae of sequences and series, and we'll get the final answer. Now students, this expression can further be written as 1 upon 65 into 75, and inside the bracket, now we have to write the sum of squares of first 11 natural numbers. So by using that formula n into n plus 1 into 2n plus 1 whole divided by 6 and putting the value of n as 11 into it, we get the value as 11 into 12 into 23 divided upon 6. Then we had the sum of first 11 natural numbers, that is just 11 into 12 divided by 2 and minus 2, which was already present in the expression. So now it becomes 1 upon 65 into 75 divided upon, this value becomes 22 into 23, this is 506, plus now this value comes out to be 66 minus 2, which is 64. So finally I can write this value as 570 divided upon 65 into 75. Now just divide up and down by 3. So we get 190 and here we get 25. Further we divide by 5 up and down. We get 38 over here and here it's just 5 into 65. So the final answer becomes 38 upon 325. So that means C option is the correct one. Now students, this was a nice problem on the topic of probability. I hope you must have understood how we have solved it. Now we move to our next problem. Now students, this is a fantastic problem on the topic of determinants. The question says if x, y, z are non-zero distinct real numbers, that means neither the value of x, y, z is 0 nor they are equal. And we are given the value of this particular determinant as 0. And we have to evaluate the expression 1 minus 1 by x into 1 minus 1 by y into 1 minus 1 upon z. Right? Now, as it is very much clear from the problem that we have to use properties of determinants and get the value of this expression. Now, just by looking at the entries in the determinant, we can analyze that we must perform the operations R1 tends to R1 minus R3 and at the same time R2 tends to R2 minus R3. Now with the help of these two operations, we'll be getting the determinant as 1 plus x minus 1 minus z, that is x minus z over here. Here we'll be getting x square minus z square and here we'll be getting x cube minus z cube, right? And we are already given the value of this determinant as 0. Now in the second row, the entries would be y minus z, y square minus z square and y cube minus z cube. And in the third row, it is 1 plus z, 1 plus z square and 1 plus z cube. Now this is one of the possible ways that I'm going to explain you. Now students, it's very much obvious that all the terms in the first row are having x minus z common. So what do? We take out x minus z from the first row, and similarly from the second row we take out y minus z. Now the determinant becomes 1. Here we get x plus z. Here we get x square plus z square plus xz. If you know the identity of a cube minus b cube, then you can use this identity and you will come to know that inside the determinant, after taking x minus z common, you will be getting x square plus z square plus xz at the place of x cube minus z cube. And similarly for the second row, it is 1. Over here it is y plus z. Here it is going to be y square plus z square plus yz. And in the third row we are having 1 plus z, 1 plus z square, 1 plus z cube. Right? And the value of this determinant is equal to 0. Now students, whenever we use the properties of determinants, our sole aim is to make that determinant simple and to create as many zeros as possible in a particular row or column. In fact, we have to create 2 zeros so as to simplify the value of that determinant, because it's a 3 by 3 order determinant. So obviously, to make it simple, our target is to create 2 zeros in a particular row or column. Now we are having the expression as x minus z into y minus z into the determinant. The first row of the determinant has elements like 1, then x plus z, then x square plus z square plus zx. In the second row, we are having 1, then y plus z, then y square plus z square plus yz. In the third row, we are having 1 plus z, then 1 plus z square, then 1 plus z cube. And the value of this entire expression is equal to 0. Now, since we are given that x, y, z are all distinct, so that means now we can divide the entire equation by x minus z as well as y minus z. And to make this determinant simpler, what we can do, we can perform the operations R2 tends to R2 minus R1 and R3 tends to R3 minus R1. Now students, you can see we will be getting the determinant as 1, then x plus z, then x square plus z square plus zx. In the second row, we'll be getting here 0. This is going to be y minus x. This is y square minus x square plus yz minus zx. And in the third row, we'll be having only z over here. And this second entry will become 1 plus z square minus x minus z. And the third entry will become 1 plus z cube minus x square minus z square minus zx. Fine. Now my intention in the upcoming steps is to create 0 in the first column at the third position. That means where right now we are having z, we'll be creating 0 over here. And after that, we will expand it to get the value of the desired expression. Now the determinant can be written as 1, then x plus z, then x square plus z square plus zx in the first row. In the second row, we were having 0, then y minus x. Now students, the expression which we had as y square minus x square plus yz minus zx can be factorized like this. You can see here it is y minus x into y plus x. Then you can take out z common from here to get y minus x in the bracket. And finally, you can take out y minus x to get y plus x plus z inside the bracket. Fine. So 3 element of this determinant now can be written as y minus x into x plus y plus z. And the third row we had as z, then 1 plus z square minus x minus z. And here we have 1 plus z cube minus x square minus z square minus zx. Fine. Now, as I told you, we'll be creating 0 at this position. To create 0, we'll be performing the operation R3 tends to R3 minus ZR1. That means I'm multiplying all the elements of the first row with Z and subtracting these elements from the elements of the third row. So now we'll be getting 1, then x plus z, then x square plus z square plus zx. Here we'll be getting 0. Again here we'll be getting 0. This value is y minus x into y minus x into x plus y plus z over here. Now you can also see this y minus x is coming common from the second row. So in the next step, we'll be just taking it outside. And at the second position of the third row, we'll be getting now 1 plus z square minus x minus z minus zx minus z square. So that means it finally comes out to be 1 minus x minus z minus zx. Fine. And similarly, we'll have to calculate the value at the third position of the third row. So it will be coming as 1 plus z cube minus x square minus z square minus zx, and it is going to be minus zx square minus z cube minus z square x. What I'm doing? I'm multiplying the elements of the first row with z and subtracting them from the elements of the third row. So now this value comes out to be 1 minus x square minus z square, then minus zx, then minus zx square, and finally minus z square x. Now student, this value seems to be big, but we are at the advantage because we have created two zeros in the first column. So now we'll be just expanding the entire determinant along the first column. Fine. Now students, what you can do, you can take out y minus x common from the elements of the second row and divide the entire equation by y minus x. Why? Because x is not equal to y. So that means now we'll be getting 1, then x plus z, then x square plus z square plus zx in the first row of the determinant, and in the second row we'll be getting 0, then 1, then x plus y plus z, and in the third row we are going to get 0, then 1 minus x minus z minus zx, and the last element is going to be 1 minus x square minus z square minus zx minus zx square and minus z square x. Fine. Now students, I will be expanding this determinant along the first column. So we'll be getting 1 minus x square minus z square minus zx minus zx square minus z square x, and minus x plus y plus z into 1 minus x minus z minus zx. Now students, you have to do little bit of calculations at this stage to finally get that expression. Now I'm just doing the calculations to let you know what do we finally get. Now students, you can see many terms in this expression are going to cancel out. Like this x square will cancel out, this z square will also cancel out, this zx is also going to cancel out, this zx square is also going to cancel out, this z square x will also cancel out. So now we are just left with the expression 1 minus x minus y minus z plus xy plus yz plus zx plus xyz. Fine. Now we finally move towards the desired expression and find its value. Now students, we have got 1 minus x minus y minus z plus xy plus yz plus zx plus xyz equal to 0, because the value of this determinant was given to us as 0. Now we are expected to find the value of this expression. Now just note these steps carefully, because I will be explaining how to get the value of this expression. If we just take the LCM, in the denominator we get xyz, in the numerator we get x minus 1 into y minus 1 into z minus 1. And if we simplify the entire expression over here, we'll be getting xyz minus xy minus zx minus yz plus x plus y plus z minus 1 whole divided upon xyz. That means we have to find the value of this expression. Now, as you can see from the equation number 1, we are already having the value of 1 minus x minus y minus z plus xy plus yz plus zx plus xyz as 0. So what you can do, you can put this value in this expression. Now just see here how I'm going to do this. I am rewriting this expression as xyz minus, I am taking minus common, and inside the bracket I will be getting 1 minus x minus y minus z plus xy plus yz plus zx. Fine. All divided upon xyz. Now as you can see from the equation number 1, the value of 1 minus x minus y minus z plus xy plus yz plus zx can be written as minus xyz. So that means now this expression becomes how much? It becomes xyz plus xyz divided upon xyz, and finally this is nothing but 2. So that means, students, B option is the correct one, and such kind of questions are generally asked in Olympiads and exams like JEE Advanced. Now students, we move towards the 9th problem of this video. Now students, as you can see, this is a problem from the topic of three-dimensional geometry. In this question, there are 3 lines L1, L2, L3 which are given to us, and they are intersecting each other pairwise to form a triangle of area delta. And in this question, we have to find the values of 2 unknowns P and Q as well as the area of this triangle, which is going to be formed when these 3 lines L1, L2, L3 will be intersecting each other pairwise. Now students, from the concepts of 3D, we know that whenever there are 2 lines in space like x minus x1 upon a1 equal to y minus y1 upon a2 equal to z minus z1 upon a3 and x minus x2 upon b1 equal to y minus y2 upon b2 equal to z minus z2 upon b3, then these 2 lines would be coplanar if the value of this determinant is 0. Now what is this determinant? In the first row we'll be having x2 minus x1, y2 minus y1 and z2 minus z1. In the second row a1, a2, a3, and in the third row b1, b2, b3. Now by the word coplanarity, we mean that these 2 lines will be lying in the same plane. Either they will be intersecting each other or they will be parallel to each other, right? Now it's very much clear that none of these 2 lines are going to be parallel. Why? Because for 2 lines to be parallel, their direction ratios must be proportional to each other. Now here you can clearly see the direction ratios of L1 are minus 1, 0, 1. For the line L2, it is 3 by 2, minus 1 by 2, minus 1 by 2. Or you can also say 3 is to minus 1 is to minus 1. Then for L3, it is 1 by 2, minus 1 by 2, then 1 by 2. Or we can say 1 is to minus 1 is to 1. So clearly, they are not proportional, right? So that means if this determinant turns out to be 0, then only one possibility will exist, that these lines, suppose I am taking L1 and L2, they will be intersecting each other in the same plane, right? Only then the value of this determinant is going to be 0, otherwise not. Now, as per the demand of the question, we'll be now putting the values involved and solve for P and Q. Now we move further. Now, if we consider the two lines as L1 and L2 and put the values in the form of a determinant, then we'll be getting determinant 3 by 2 because it is going to be 3 minus 3 by 2, and then 2 minus P by 2, and then we have minus half, right? In the second row, we are going to have minus 1, then 0, then 1. And in the third row, we'll be having 3, minus 1, then minus 1. Now the value of this determinant is going to be 0. Now let us solve it. We'll be getting 3 by 2 minus 2 minus P by 2 into minus 2. I am just expanding it along the first row. Then minus half into 1 equal to 0. So from here we'll be getting how much? It is going to be 1 plus 4 minus P equal to 0, or P will be equal to just 5, right? Now students, similarly, if we consider another set of lines, we'll be getting the value of Q. Now to get the value of Q, let's take the first line and the third line, that is L1 and L3, because again these two lines will also be intersecting each other pairwise in the same plane. Now if we consider L1 and L3, then the determinant is going to be determinant 3 minus Q by 2, right? Then 0, then minus 1. In the second row, we'll be having 3, minus 1, then minus 1, and 1 minus 1, 1 equal to 0. Now students, I hope you will be able to understand that why we are taking all these three lines L1, L2 and L3 to be coplanar, because if they are intersecting each other pairwise to form a triangle, then obviously the triangle will form a particular plane, because triangle can exist in a particular plane. Triangle, if we extend the triangular region, then automatically we'll be getting a plane, because whenever these three lines intersect each other pairwise, they will be forming 3 points of intersection, and if we join those 3 points of intersection, obviously we'll be getting a triangle. Now students, if we solve this determinant along the first row, we'll be getting 3 minus Q by 2 into minus 2, then minus 1 into minus 2 equal to 0. So from here we'll be getting Q minus 3 plus 2 equal to 0, or Q is just equal to 1, right? Now we have solved for both of these values, P equal to 5 and Q equal to 1. The only thing is left is to find the value of delta. Now to find the value of delta, our approach is going to be, first of all, find the 3 points of intersection. That means suppose if this is L1, this is L2 and this is L3, then we'll be finding the mutual point of intersection of L1 and L2, similarly for L1 and L3, and similarly for L2 and L3. After we get the points of intersection, then we can directly, by using the formula of cross product, find the value of the area of this triangle. Fine. Now we move further. Now students, let us find the point of intersection of L1 and L2. Now to find the point of intersection of these two lines L1 and L2, first of all, I am writing the general point of the line L. So from here I get the values of x as minus lambda plus 3. What I am doing, I am just putting the values x minus 3 upon minus 1 equal to y minus 2 upon 0 equal to z minus 1 divided by 1 equal to lambda. So from here I will be getting the general point of this line as x minus lambda plus 3. y equal to just 2 and z equal to lambda plus 1, right? Now similarly for line L2, now we write the values by putting all of these terms. 2x minus 3 divided by 3 equal to 2y minus p divided by minus 1 equal to 2z minus 3 divided by minus 1 equal to mu. So from here we'll be getting the general point of the line L2 as 3 mu plus 3 divided by 2, then y as 5 minus mu divided by 2, and then z as minus mu plus 3 divided by 2. Now students, whenever two lines are intersecting each other, then obviously for that particular point of intersection, the values of x, y and z will be equal to each other, right? That means we have to now equate them. And since there are two variables involved, lambda and mu, so only two of the equations would be sufficient. But we can check in the third point by putting the values of lambda and mu, just to confirm whether we are getting the right point of intersection or not. But to solve for lambda and mu, only two equations are sufficient. Now what I do, I just put minus lambda plus 3 equal to 3 mu plus 3 divided by 2. And from here I get the equation as minus 2 lambda plus 6 equal to 3 mu plus 3, right? And from here finally we get minus 2 lambda is equal to 3 mu minus 3. Now when we equate the values of y in these two parametric equations, we'll be getting 2 equal to 5 minus mu divided by 2, or 5 minus mu is equal to 4, or mu is equal to just 1. Fine. Now what we have to do, we have to put this value of mu equal to 1 in this first equation. So from here we'll be getting minus 2 lambda is equal to 3 minus 3. So that means lambda is nothing but 0. Right students? Now we have got the values of lambda and mu. You can now put lambda here to get value of z as just 1. And in the second equation, if you put mu as 1, you'll be getting 2 upon 2 as the value of z. That means z is equal to 1. So that means z from here is 1 as well as from here it is 1. So it's same. So that confirms that the values of lambda and mu are correct. That means we are getting the point of intersection, common point of intersection. And now we find the point of intersection by putting the values of lambda or mu, right? If you want to put the value of lambda, you have to use the first equation. If you want to put the value of mu, you have to use the second equation. That means second line. Now the point of intersection comes as 3, 2 and 1, right? Now students, similarly, by using the same process, you have to find the point of intersection of L2 and L3, and as well as for L3 and L1. Now we move further. Now students, we find the point of intersection of L2 and L3, right? So now I put 2x minus 3 divided upon 3 equal to 2y minus p was 5. So divided upon minus 1 equal to 2z minus 3 divided upon minus 1 equal to L. This is the parametric equation that I have written. So from here x becomes 3L plus 3 divided by 2. Y becomes minus L plus 5 divided by 2. And z becomes minus L plus 3 divided by 2. Right? Now we use the line L3. It is 2x minus q. Now q we have found as 1. So it is 2x minus 1 divided upon 1 equal to 2y minus 5 divided upon minus 1 equal to 2z minus 5 divided upon 1 equal to m. So the values of x, y, z are going to be m plus 1 divided by 2. Y is going to be minus m plus 5 divided by 2. Z is going to be m plus 5 divided by 2, right? Now you know the process. we'll be equating the values of x, y and z, and after that we'll be getting the equations and we'll solve. Now let's equate the values of x first. We'll be getting 3l plus 3 divided by 2 equal to m plus 1 divided by 2. So that means 3l plus 3 is equal to m plus 1, or m is equal to 3l plus 2, right? So this is the first equation. Similarly, we equate the second values, that is the values of y. We'll be getting minus m plus 5 divided by 2 equal to minus l plus 5 divided by 2. So from here, we'll be getting the values of m and l equal to each other. Right, students? Now we'll be solving these two equations. Now m was 3l plus 2, and we also got the second equation as l equal to m. So here I'm putting m equal to l. So it becomes l minus 3l equal to 2, or minus 2l equal to 2, or l is equal to minus 1. So that means m is also equal to minus 1, right? Now what do we do? To get the point of intersection, either use the value of L or use the value of M. If you want to use the value of L, you have to put it in the equation of L2. If you want to use the value of M, you have to put it in the equation of L3. And you can also confirm whether we are getting the same point of intersection just by putting the values of L or M in the coordinates of Z. Now let's find now the point of intersection. It becomes, I'm using the value of L, it becomes minus 3 plus 3, that means 0. Then we have this is 6 by 2, which is 3, and then lastly we have 2. So that means the second point of the triangle, or the second vertex of the triangle, is 0, 3 and 2. Now students, we have to just find the third point of intersection. Now for this, I'm going to take intersection of L1 and L3, right? Now to find the point of intersection of L1 and L3, for L1 again we'll be writing the equation in parametric form. So this time I am changing the name of the variable from lambda to a, right? So it becomes, I'm now using x minus 3 upon minus 1 equal to y minus 2 divided by 0 equal to z minus 1 divided by 1 equal to a. So the point becomes minus a plus 3 and 2, and then we have a plus 1. Similarly, now I'm taking the third line L3 as, and 2x minus 1 divided by 1 equal to 2y minus 5 divided upon minus 1 equal to 2z minus 5 divided upon 1, and putting it equal to b. I have just changed the name of the variables. So this time the values of x, y, z are going to be b plus 1 divided by 2, then minus b plus 5 divided by 2, then b plus 5 divided by 2, right? Now we'll be equating the values of x and y and finding the variables involved, that is a and b, and after that we'll be getting the point of intersection. Now we equate minus a plus 3 equal to b plus 1 by 2. So from here we get minus 2a plus 6 equal to b plus 1, or b equal to minus 2a plus 5. And when we equate the coordinates of y, we get 2 equal to minus b plus 5 divided by 2, or 4 equal to minus b plus 5, or b equal to 1. Now if b is equal to 1, then 1 will be equal to minus 2a plus 5. We have substituted the value of b in the first equation. So now we'll be getting minus 4 equal to minus 2a, or a is equal to just 2. Fine. Now students, we lastly find the point of intersection. I'm just using the values of a in the equation of L1. So the point comes out to be 1, because it is 3 minus 2, comma 2, and then we have 3. right? So students, now we have found all the 3 points of intersection. So that means if this is L1, this is L2 and this is L3, then this point has the coordinates as 3, 2, 1. That was our first point. Second, for L2 and L3, it was 0, 3 and 2. And lastly, for L1 and L3, it is going to be 1, 2 and 3. Fine. Now we know that whenever there are two straight lines, or you can say two arms of a triangle, like if this is the triangle ABC, then to find the area of the triangle ABC in 3D, what do? We find it like half mod AB cross AC, right? This is the technique which we use, or the formula which we use. So now what we have to do, we have to, let's call this point as A, this point as B, and this point as C. Now we have to use the same formula, find the vectors AB and AC, and find their cross product, and then put the values in this formula to get the area of triangle. Now students, if this is the triangle ABC, A was 3, 2, 1, B is 0, 3, 2, and C is 1, 2, 3, then the vector AB is going to be 3i minus j minus k, right? I hope you must be knowing how to find the vector AB. Similarly, the vector AC is going to be 2i minus 2k. Fine. Now the area of this triangle delta is going to be half. Now I find the cross product of these two vectors, that is AB cross AC. So this becomes I j k. You can also find AC cross AB, because ultimately we are concerned with the magnitude, because finally we have to take the modulus of that. So now here it is 3, AB is 3 minus 1, then minus 1, and in the last row we are going to have 2, 0 minus 2, right? So now this becomes half, and I'm just putting modulus over here because the cross product will give us the vector, then we have to find its magnitude. So half modulus of the vector which we are going to get, let's just expand this determinant along the first row, then it is going to be I into 2, then minus j into minus 4, then plus 2k, right? So it becomes, I'm just taking out 2 common, so it becomes modulus of I plus 2j plus k, right? So students, delta becomes under root of 1 square plus 2 square plus 1 square. So it becomes under root of 6. So that means delta is equal to square root of 6 square units. Now we have found all the values, p equal to 5, q is equal to 1, and delta is equal to root 6. So hence C option is the correct one. Now students, this was a fantastic problem on the basic concepts of three-dimensional geometry. Such kind of questions can be asked anywhere, like in the exams like JEE Main or JEE Advanced. They may be asked in the form of single correct or multiple correct or comprehension type of questions. So never ignore such kind of concepts because they are very important. Now students, this is another wonderful problem that I'm going to take up, and this is going to be the last question of this video. The question says, If the equations of the internal angular bisectors of a triangle are 2x plus y minus 9 equal to 0, 6x minus 7y plus 23 equal to 0, and x minus 4y plus 18 equal to 0, and its in radius is given to be 2 units, then find its area. Now we'll be using the concepts of trigonometry as well as coordinate geometry to solve this problem. Let us consider a triangle ABC and let its internal angular bisectors intersect each other at the point I. That means this I is going to be the in center for this triangle. Now suppose we drop a perpendicular from I onto the side BC, then this perpendicular's length would be the in radius for this triangle, that is small r. Similarly, we can drop perpendicular from I onto AB, again R, and similarly from I to AC, again it is going to be R. Now students, I will be finding the area of triangle ABC by writing it as the sum of the areas of three small triangles that are being created inside it, and they are triangle IAB plus triangle IBC plus triangle ICA, right? Now we know that to solve the area of any triangle, we can write it as half BC sin A. Now what is half BC sin A? It is half the product of two sides of the triangle into sine of the included angle, right? Now just see here, IA will be small r into cosecant A by 2. You can easily get this value by using basic trigonometry. Similarly, IB will be r cosecant B by 2, and similarly IC will be r cosecant C by 2, right? Now let's consider first of all area of triangle IBC. Now IBC can be written as half IB into IC into sine of the angle BIC. Now what is this BIC angle going to be? Because this is B by 2, this is C by 2, because they are angular bisectors. So that means angle BIC is going to be what? It is going to be pi minus B plus C by 2. Now pi minus B plus C by 2 is nothing but pi by 2 plus A by 2. Why I'm writing like this? Because B plus C is nothing but pi minus A. So when you simplify this expression, you'll be getting pi by 2 plus A by 2. So that means here I can write sine of pi by 2 plus A by 2. And IB we know is r cosecant B by 2, IC is r cosecant C by 2. So finally it becomes half r square cosecant B by 2 into cosecant C by 2 into cos of A by 2. Why I'm writing cos of A by 2? Because sine 90 plus theta is nothing but cos theta. Now students, in the same way, we have to find the values for area of triangle IAB as well as ICA, and then we'll be adding all of them. Now students, if we continue in the same way, we can write area of triangle ABC equal to half r square outside the bracket, and inside the bracket we can write cosecant B by 2 into cosecant C by 2 into cos of A by 2 plus cosecant A by 2 into cosecant B by 2 into cos of C by 2 plus cosecant A by 2 into cosecant C by 2 into cos of B by 2. Now if we simplify it further, this is half r square into cos of A by 2 divided upon sin B by 2 into sin C by 2 plus cos of C by 2 divided upon sine of a by 2 into sine of b by 2, and similarly it is the third term which can be written as cos of b by 2 divided upon sine a by 2 into sine c by 2. Now if we take the LCM of all the terms, we can write here sine a by 2 into sine b by 2 into sine c by 2 as the LCM, and in the numerator we'll be getting sine a by 2 into cos a by 2. Now this sine a by 2 into cos a by 2 is nothing but half sine a, right? So this is just half sine a plus half sine c plus half sine b. Fine. Finally, this can be written as r square divided by 4 into sine of a plus sine of b plus sine of c whole divided upon sine a by 2 sine b by 2 into sine c by 2. Right? Now we simplify it further. Now students, this can be written as r square divided by 4 into this sine a plus sine b plus sine c can now be written as 2 sine a plus b by 2 into cos of a minus b by 2, plus this sine c can be written as 2 sine c by 2 into cos c by 2, right? And in the denominator we are already having sine a by 2 into sine b by 2 into sine c by 2. Now finally this is r square upon 4 into, now just simplify this expression. This is going to be 2 cos c by 2 out. Why? Because this sine a plus b by 2 is nothing but cos of c by 2. And inside the bracket we get cos of a minus b by 2 plus sine c by 2. Now sine c by 2 can be written as cos of a plus b by 2. Right? Because c is nothing but pi minus a plus b. And in the denominator we have sine a by 2 into sine b by 2 into sine c by 2. This is r square by 4 into, now in the numerator when we simplify this expression we are going to get 4 cos a by 2 cos b by 2 cos c by 2, right? And in the denominator now we have sine a by 2 sine b by 2 sine c by 2. So now finally I can rewrite this expression as r square into cot a by 2 into cot b by 2 into cot c by 2. Now students, why I have derived this formula for you? It's only because it's not generally given in most of the books. You can derive like this and then you can put in the values of cot a by 2, cot b by 2, cot c by 2 and find the area of the triangle. Now how to get the values of cot a by 2, cot b by 2, cot c by 2? That can be done by using the concepts of coordinate geometry. Now we move further and see how we can do this. Now students, let me make the figure of the question. Let us assume the triangle to be ABC. This is I, suppose. Now the equations of the angular bisectors are given to be as 2x plus y minus 9 equal to 0. Second one is 6x minus 7y plus 23 equal to 0. And thirdly, it is x minus 4y plus 18 equal to 0. Right? I think you must be aware of the formula to find the angle between two straight lines. If suppose this is the angle theta between any two straight lines whose slopes are m1 and m2, then we know that tan theta is equal to plus minus m1 minus m2 upon 1 plus m1 m2. Now whether we have to attach plus sign to this value or minus sign, that actually depends upon the theta. If theta is acute, then the value of tan theta has to be positive. So accordingly, we can decide about the sign. And if theta is obtuse, then tan theta has to be negative. Fine. Now, how we can use this particular formula in this question? We know that the slope of IA, it is going to be -2. For IB, it is going to be 6/7. And for IC, it is going to be 1/4. Right? And we also know that this was B/2, this is C/2, and this is A/2. Fine. So if I talk about angle BIC, as I have told you earlier, this is going to be pi/2 plus A/2. Fine. So that means if suppose I want to find the angle between IB and IC, that is BIC, then it is going to be pi/2 plus A/2. So if I want to get the tangent of this, tan of pi/2 plus A/2, it is going to be how much? It is going to be minus cot of A/2. Fine. So by using this particular formula, I can definitely get the value of minus cot A/2. And similarly, I can get the value of minus cot B/2. And lastly, we can get the value of minus cot C/2 in the same way. And after that, we can just put in these values into the formula which we have derived just now and get the area of the triangle. Fine. Now students, you can see the slope of IB is 6/7, slope of IC is 1/4. So minus cot A/2 will be equal to how much? I know that this cot A/2 has to be positive because A/2 is going to be acute. So cot of A/2 has to be positive, minus cot A/2 has to be negative, right? So what I'm going to do, first of all, I'm finding the value of the expression m1 minus m2 upon 1 plus m1 m2, and after that I will be just attaching the sign plus or minus so that the final value comes out to be negative. Now just see, I'm doing this. This is going to be 6/7 minus 1/4 upon 1 plus 6/7 into 1/4. Now this value comes out to be 28 would be the LCM. So it is 24 minus 7 divided by 28 whole divided upon, this is going to be 28 plus 6, that is 34 upon 28. So final value comes out to be 17 upon 34 and nothing but just half. Fine. Now this is the value of m1 minus m2 upon 1 plus m1 m2. Now I have told you that we have to select this sign plus or minus so that minus cot A/2 finally turns out to be negative. So that means this value I will be taking as minus half. So it means cot of A/2 will be 1/2, right? Now students, I hope you must have got the concept of the question. Now we'll be similarly getting the values of cot B/2 and cot C/2. Now we know that this angle is B/2. So this angle BIA will come out to be pi/2 plus C/2. Similarly, the angle angle CIA will come out to be pi plus B/2 or pi/2 plus B/2. Fine. Now let us find their values as well, cot B/2 and cot C/2. Now students, to find the value of cot B/2, we'll have to find the angle between the internal angular bisectors IA and IC, as you can see it from the figure. So now I'm writing tan of pi/2 plus B/2. It is going to be how much? It is just minus cot B/2. And if I use that formula m1 minus m2 upon 1 plus m1 m2, I will be getting the values as minus 2 minus 1 by 4 divided upon 1 plus minus 2 into 1 by 4, right? Because the slopes of these two lines are minus 2 and 1 by 4. Now the sign will be deciding later on. So it is going to be how much? It is going to be minus 9 by 4 divided upon half. Fine. So this becomes minus 9 by 2. Now obviously minus cot b by 2 has to be negative. So that means this is just minus 9 by 2. That means we have to just attach plus sign to it, because plus outside and inside minus 9 by 2, it will become minus 9 by 2. So that means cot b by 2 comes out to be 9 by 2. Fine. And similarly, if we consider the lines IA and IB, we can find the value of tan of pi by 2 plus c by 2 equal to minus cot of c by 2 as how much? Let us do the calculations. Now, by applying the formula m1 minus m2 upon 1 plus m1 m2, it is going to be minus 2 minus 6 by 7 divided upon 1 plus minus 2 into 6 by 7. So this value comes out to be minus 14 minus 6, that is minus 20 by 7 divided upon, it is going to be 1 minus 12 by 7 or minus 5 by 7. So finally it comes out to be just 4. Now we'll have to attach minus sign to 4. Why? Because minus cot c by 2 has to be negative. So that means this is going to be minus 4. Or we can say cot c by 2 is just 4. Fine. Now students, we have got the values of cot a by 2, cot b by 2 and cot c by 2. So the question is now almost finished. Now I'm going back to the original formula, and that was delta equal to r square into cot a by 2 into cot b by 2 into cot c by 2. Now students, we have been given the value of r as 2, so it is going to be 4 into. Let us now put the values of cot a by 2, cot b by 2, cot c by 2. So what do we get from here? We get half into 9 by 2 into 4. So finally the answer comes out to be 36 square units, right? So this was the question all about, and it was a fantastic problem. So we get C option as the correct one. Now students, here I'm going to end this video. I hope you must have enjoyed all the problems. All of these questions were based upon the concepts which are generally asked in different types of competitive exams like JEE Main and JEE Advanced. If you practice these problems at home, then I can definitely ensure you people, you will be gaining a lot of knowledge and it will help you to crack these exams. I will also recommend you people to buy this book so that you can get enough practice on different concepts of class 11th and 12th. Thanks. Subscribe to my channel and please share it among your friends.